Okay, so we're going to look at some more examples on solving quadratic inequalities. And so this will be the third set of problems. Remember in the previous two sets of examples, we were using these steps to solving a quadratic inequality. So let's look at number, and this is going to be number 6 in our set. So we have x squared minus 16 is greater than 0. So I want to solve this quadratic inequality. Notice it's an inequality because of that inequality symbol. It's quadratic because you see that x squared there. And so the process, remember the process is, first thing you're going to do is make sure it's in standard form, so you have that 0 on the other side, and I do. Then the next thing you want to do is identify the zeros. To identify the zeros, you've got to make sure it's in factored form first. So in this case, let's go ahead and factor this. So all of our problems are factorable. So when I factor x squared minus 16, I get x minus 4 times x plus 4 is greater than 0. Okay? So the solutions to this inequality are going to be the same as the solutions to this. So it is so much easier to solve a quadratic inequality or a polynomial inequality if you factored it, or if you found the zeros, and that's the next step. So now the next step is to find the zeros. So remember, those zeros are sometimes called critical numbers or boundary points. So let's find out critical numbers or our boundary points. To do that, we're going to set each of those factors, and there are 2 of them here, equal to 0. So x minus 4 equals 0, x plus 4 equals 0. When I set x minus 4 equals 0, I get x to be 4. Over here, I get x to be negative 4. So my zeros are 4, negative 4. So those are my zeros. All right, now once you find your zeros, remember the next step is to put those on the number line, and you got to put them in numerical order. So when I put those on the number line, negative 4 is going to be listed first, and 4 will be listed second. Remember, when you put your zeros on the number line, you are actually dividing the number line, and there are 2 zeros, so you're actually dividing the number line into 3 intervals. Negative infinity to negative 4, negative 4 to 4, and then 4 to infinity. Okay? And so we got to determine which of those intervals right here will be solutions to this inequality. And in the process, I've got to look at this product right here. I want this product to be greater than 0. I want this polynomial to be greater than 0. Remember, greater than 0 means a positive number. So I want this product to be positive. Okay? So what I got to do now is determine, well, which of these intervals will make this product positive? And that's what I got to find. Okay, so then to do that, remember, you have to use these test points, something called test points. And then we can use those test points to determine the sign of this polynomial, determine what sign we have. So to determine the test points, we got to pick, and there are 3 intervals, so you can use 3 test points. We got to pick a test point in this one, we got to pick a test point here, and we have to pick a test point there. So between negative infinity and negative 4, let's use the test point negative 6. You can use any real number between negative infinity and negative 4. It could be a decimal, fraction, whatever you want. It's so much easier to use an integer. All right, so negative 6 is in here, so I'm going to use negative 6. Between negative 4 and 4, the easiest integer to use is 0. And then from 4 to infinity, let's just say 6. All right, so those are my 3 test points. Now, once you find your test points, once you determine your test points, then you're going to go back here and you're going to substitute those test points here to determine if this product's positive or negative. Before I go any further, remember, these are your zeros, right? So these are your zeros right here. What does that mean? Well, that means that when x is negative 4, this product is 0. When x is 4, this product is 0. Makes sense, because look, if x is 4, what's 4 minus 4? 0. What's 4 plus 4? 8. 0 times 8 is 0. All right. Also notice, so there's no equal sign, right? So that's a strict inequality. Strict inequality means there's no equal sign. It's strictly greater than or less than. So there's no equal sign. Okay, so let's use negative 6. So we go back to the factored part. If x is negative 6, I get negative 6 minus 4 times negative 6 plus 4, right? Negative 6 minus 4, negative 6 plus 4. Negative 6 and a negative 4 is negative. That's a negative 10. Negative 6 plus 4, that's a negative because that's negative 2. A negative times a negative is a positive. Is that interval? Is this interval going to be a solution? Yes, because I want the positive intervals. I want the intervals that in which the values of x will be positive. Well, we'll make this product positive, I should say. All right, so when x is 0, will 0 make this product positive or make this product negative? Well, let's see. If x is 0, I get 0 minus 4 times 0 plus 4, right? 0 minus 4, 0 plus 4. 0 minus 4 is negative. 0 plus 4 is positive. A negative times a positive is a negative. So is this interval, will the numbers in this interval be solutions to this inequality? No, because the numbers in this interval will make this product negative, and I'm looking for greater than 0, so I want this to be positive. If x is 6, that's a 6, I get 6 minus 4, 6 plus 4. Well, 6 minus 4 is positive. 6 plus 4 is also positive. A positive times a positive is a positive. Is that something I want? The answer is yes. So those are my two intervals. Okay? Now, there's no equal sign, right? So what that means is that when you actually use those two zeros in your interval notation, you're going to have to use parentheses. Parentheses. Because there's no equal sign there. So what's your solution? Well, and always remember, you always must go from left to right, from smallest to largest. So your solution must be listed in the correct order. So you go from negative infinity to negative 4. See this interval here. So negative infinity to negative 4 with parentheses on negative 4, because there's no equal sign. You always note that whenever you use infinity and negative infinity, you're always going to use parentheses. No, never a bracket with negative infinity or infinity. You're going to say union, you're going to use that U symbol, and then for the next interval is from 4 to infinity. So parentheses 4 to infinity. And that's it. That is number 6. Very simple. Not difficult at all. So what you found is that any real number between negative infinity and negative 4 or between 4 and infinity will make this inequality a positive number. Okay? You cannot use negative 4 and you cannot use 4, because if you use negative 4, that's why you see parentheses there. That makes this 0, and you're not including 0. There's no equal sign. So that's why you see brackets on negative 4 and 4. All right, number 7. So in number 7, we have this one. We have 4x squared minus 8x is less than negative 3. So 4x squared minus 8x is less than negative 3. So remember our steps. We want to solve this quadratic inequality. So it is quadratic. These x squared, it is an inequality, the less than. But remember, it's not in standard form. So remember, the first step is that you have to have 0 on one side. So let's go ahead and add 3 to both sides. So I get 4x squared minus 8x plus 3 is less than 0. Okay? Then the next step is to factor this trinomial right here, this quadratic trinomial. So let's go ahead and do that. Less than 0. All right, so when I factor this left side, make sure you put less than 0 still. You got to make it mathematically correct. So let's try 2x, and 3 and 1. So let's put 3 here, 1 there. The last sign's positive. That means both of these signs are the same. They would be negative. And so that's what I get. So let's double check this. Let's make sure that's correct. 2x times 2x is 4x squared. The outer is a negative 2x. The inner is a negative 6x. Add them up, I get negative 8x. Negative 3 times negative 1 is a positive 3. All right, so that's correct. Now, once you factor, remember the next step is to find those zeros, sometimes called critical numbers or boundary points. So let's find those critical numbers. So my zeros are, all right, so I got to set each factor equal to 0. So 2x minus 3 equals 0. 2x minus 1 equals 0, right? And so when 2x minus 3 equals 0, that means 2x equals 3, which means x equals 3 halves. Over here, 2x equal 1, so x equals 1 half, right? Okay. Okay, so now we'll put those numbers on the number line. Now you got to be careful. For some of you, you got to know that 3 halves is 1.5 and that 1 half is 0.5. So on the number line, 1 half comes first, and then 3 halves is next. Okay. All right. So those are your zeros. Now remember, those are zeros because that means. So those are your zeros because that means if I substitute 1 half into the problem here, I'm going to get 0 as this product. If I put 3 halves, I'm going to get 0 as a product as well. Makes sense because look, 2 times a half, if you check 1 half, 2 times a half is 1. 1 minus 3 is a negative 2. 2 times a half is 1. 1 minus 1 is 0. Negative 2 times 0 is 0, right? Okay. All right, now we got to pick test points in this interval. So notice that those two zeros divide the number line into 3 intervals. Negative infinity to 1 half, 1 half to 3 halves, and then 3 halves to infinity. And so what I'm interested in is finding the values, finding those intervals where these real numbers will make this product less than 0, meaning negative. I need this product to be negative. Notice it's a strict inequality. There's no equal sign. So it's a strict inequality, so I just want negative. Okay, let's pick a test point between negative infinity and 1 half. So the easiest real number to use between negative infinity and 1 half is 0, right? 1 half is in here. Now be careful here. So always try to use an integer. Is there an integer between 1 half and 3 halves? Yes, there's only one integer that's between 1 half and 3 halves. What is that? The number 1. That's the only one. So if you want to use any other number, though, you could. You could say 1.2. You could say 0.75. Any real number. There are an infinite number of real numbers between 1 half and 3 halves. But it makes things so much easier if your test points are integers. So for the next test point, the third one, give me an integer. Always use an integer if possible. Give me an integer that's greater than 3 halves. So an integer greater than 3 halves, let's say, is 5, right? 5 is greater than 3 halves. So those are my test points. So now what I'm going to do is I'm going to substitute those test points into this factored part to determine if the product's negative or positive. So let's use 0. So in place of 0, in place of x, right, I'm going to substitute 0. So look, 2 times 0 is 0. So I get 0 minus 3. 2 times 0 is 0. So I get 0 minus 1. 0 minus 3 is negative. 0 minus 1 is negative. A negative times a negative is a positive. So is this interval going to be a solution? You want negative, right? Less than 0 is negative. So that's not going to be a solution. Let's try 1. 2 times 1 is 2. So I get 2 minus 3. 2 times 1 is 2. 2 minus 1. 2 minus 3 is negative. It's actually negative 1. 2 minus 1 is positive. It's actually a positive 1. A negative times a positive is a negative. So is that interval going to be a solution? The answer is yes. Let's try 5. 2 times 5 is 10. So I got 10 minus 3. 2 times 5 is 10. So you got 10 minus 1. 10 minus 3 is a positive number. It's actually 7. 10 minus 1 is a positive number. It's actually 9. A positive times a positive is a positive. Is that something you want? The answer is no. So the only solution is this interval right here. Okay, now you got to remember, there's no equal sign. So for these zeros, you're going to use parentheses and put the word PAR or parentheses. So the solution will be parentheses 1 half, comma, 3 halves, parentheses. And that's your answer. So any real number between 1 half and 3 halves will make this inequality a true statement, or this inequality a true statement, or this inequality a true statement. Okay? All right, so that was number 7. Let's look at number 8. So in number 8, let's suppose we had this one. We had x squared plus 5x plus 6 is greater than 0. So x squared plus 5x plus 6 is greater than 0. Okay, so first of all, notice that 0 is on that other side. So the next step is to factor this trinomial. So I get x plus 3, x plus 2 is greater than 0. And I'm going to set, so now we got to find the zeros, right? So or the critical numbers. So we got to find those zeros. To find the zeros, you got to set each factor equal to 0. And so when I set each factor equal to 0, I get x equals -3 and x equals -2. So those are my zeros. So my zeros are -3, -2. Now we've got to remember, you got to put those zeros on the number line. Make sure you understand that it has to be in correct order from smallest to largest. -3 is smaller than -2. So we're going to put -3 first and then -2. Okay? All right. Now notice those are your zeros, right? So these are your zeros. That means that when x is -3, this product is 0. When x is -2, this product is 0. Also notice there's no equal sign, so it's a strict inequality. And I want this product right here to be greater than 0, meaning I want this product to be positive. So I'm looking for intervals that will be positive. So now I've got to pick test points. Give me a test point between -infinity and -3. Let's say -5. Now be careful here. Remember we said try to use integers for test points if possible. There is no integer between -3 and -2. So we have to resort to a decimal or a fraction. Let's go ahead and use a decimal. So let's go ahead and pick a nice decimal that's between -3 and -2. And try using 0.5 whenever possible. So do y'all agree that -2.5 is within -3 and -2? Okay. So I'm going to use -2.5 as a test point. For this test point, I can use an integer. There are an infinite number of integers here. So give me a nice integer to use. Well, do y'all agree that 0 is a nice one? Use 0. 0 is a test point there. So now I'm going to substitute these test points into the original problem and see what we get. So let's start with -5. So I have -5 plus 3 times -5 plus 2. -5 plus 3 is negative. -5 plus 2 is also negative. A negative times a negative is a positive. So no matter what value I pick between -infinity and -3, this product will be positive. Is that something I want? Yes. So I'm going to check it off. Let's try -2.5. So if x is -2.5, I get -2.5 plus 3 times -2.5 plus 2. Well, -2.5 plus 3 is positive, right? It's actually 0.5. -2.5 plus 2 is negative. It's actually -0.5. A positive times a negative is a negative. So is this interval from -3 to -2 going to be a solution? Nope. Because I want only positives. So any number between -3 and -2 will make this product negative, and I want it to be positive. Greater than 0 is positive. So I'm not going to use it. If x is 0, I get 0 plus 3 times 0 plus 2. Well, 0 plus 3 is positive. 0 plus 2 is positive. Positive times a positive is a positive. Is that interval going to be a solution? The answer is yes. Okay. Now, remember, there's no equal sign, right? So that means that these zeros, you're going to use parentheses, not brackets. So parentheses. Okay, so I have two intervals for my solutions. You always go from left to right in numerical order. They must be listed correctly. So your solutions are going to be negative infinity to negative 3, parentheses, union, make sure you use a union symbol, and then from negative 2 to infinity. And that's it. So any real number that's in any of those intervals here will make this original inequality a true statement. All right, let's do one more. So this will be number 9. So let's do number 9. So in number 9, we have 4x squared minus 9x plus 2 is less than or equal to 0. So 4x squared minus 9x plus 2 is less than or equal to 0. All right, so it's already in standard form. 0 is already on the other side. So now what we have to do is we got to find the 0. So we're going to factor this polynomial. So when I factor it, don't forget to say less than or equal to 0. You must say that. When I factor it, what's going to work will be 4x and x, 2 and 1. Last sign's positive, so they all have to be the same sign, and they'll both be negative. And let's double check. 4x times x is 4x squared. Negative 1 times negative 2 is a positive 2. The outer is negative 8x. The inner is a negative 1x. You get negative 9x when you add them. So that's correct. So now we're going to find the critical numbers. So we're going to find those critical numbers right here. The boundary points are the zeros. Those all mean the same thing in this case. So the zeros are, so we're going to set each of those equal to 0. Each of those factors equal to 0. And we're going to solve each of those linear equations. So 4x equal 1, x is 1/4. Here x is 2. So those are your zeros. Your zeros are 1/4 and 2. All right, so now you're going to put that on the number line. So make sure you put them in numerical order. So 1/4 will go first and 2 will go second. Now those are your zeros. So that means if you substitute 1/4 or 2 into any of these expressions here, you're going to get 0. And notice there's an equal sign, right? So I want this product to be less than 0, negative or 0, because the equal sign. All right, so I know the 0 ones. I know what values of x will make this 0 because I found them. So when I write my solution, I'm going to have brackets here. I'm going to have a bracket with this one as well. Okay? So there's no equal sign, you would use parentheses. Okay, so now we got to pick test points. So give me a number that's in this interval right here between negative infinity and 1/4. So what do you think would be the easiest to use? 0, right? I would pick 0. Now you could pick any real number, or remember always use integers if you can, or any integer that's here. You will the product you get will still be the same. When I say the same, I mean if you use one test point and it's positive, then all the others better be positive as well. If you use one test point it's negative, then all the others better be negative. That's what I mean by the same. Give me a test point between 1/4 and 2. Always use an integer if possible. So the only one actually is what? 1, right? Give me an integer, give me a test point. Always try and use an integer if possible. That's greater than 2. Let's say 3. All right, so those are my test points. So now we're going to substitute back into the factor part. You can go here or you can go here. It does not matter. I always go to the factor part because it's quicker to do. So if x is 0, 4 times 0 is 0. So I get 0 minus 1 times 0 minus 2. Well, 0 minus 1 is negative. 0 minus 2 is negative. A negative times a negative is a negative. That's something you want? The answer is yes. So no matter what value, no matter what test point I use here, when I substitute into the inequality, this product will always be negative. So that's going to be a solution. This interval will be a solution. Okay? Oops, sorry. A negative times a negative is a what? Positive, I'm so sorry. So that's not one I want. A negative times a negative is a positive. Okay, let's do number 1. When x is 1, 4 times 1 is 4, right? So I get 4 minus 1 times, and then when x is 1, I get 1 minus 2. 4 minus 1 is 3, that's positive. 1 minus 2 is negative 1, so that's negative. A positive times a negative is a negative, right? No matter what value of x I choose between 1/4 and 2, that will make this product negative. Is that something I want? The answer is yes. So I'm going to check it off. If x is 3, 4 times 3 is 12. So I get 12 minus 1 times 12 minus 2. Times 3 minus 2. I'm sorry about that as well. Okay. 4 times 3 is 12. So I get 12 minus 1. X is 3, so I get 3 minus 2. Well, 12 minus 1 is 10, so that's positive. 3 minus 2 is 1, so that's positive. A positive times a positive is a positive. What I found is that no matter what test value I use, test point, 3, 4.7, 100, no matter what test point I use that's in this interval, that test point will make this product positive. Is that something I want? No, I want negative, so I'm not going to use that. So what I found is that the only interval that's a solution is this interval here. Also remember there's an equal sign, so I've got to use brackets. So my solution will be from bracket 1/4, comma, all the way to 2 with a bracket. And that is it. All right, so you found the solutions, you found all the real numbers. That's going to be solutions to this inequality. Okay, so any real number that's in here will make this inequality a negative number or 0. And so that is the 4 problems, the extra 4 problems on solving quadratic inequalities.